Welcome to the Explainer. Today, we're going to look under the hood of modern AI. You hear these terms all the time, right? Machine learning, deep learning, and honestly, they get thrown around like they mean the same thing, but they don't, not at all. One is built on math that's literally centuries old, and the other, well, the other is this powerful brain-inspired evolution that comes with a pretty serious catch. So let's break down the difference. Okay, so let's just dive right in. Think about it. Almost every piece of AI you touch, from what pops up in your social media feed to the dream of self-driving cars, it's all running on one of these two technologies. And knowing the difference, it's not just some technical trivia. It is absolutely crucial for understanding where our world is actually headed. So, here's what we're going to do. We're going to break down these big differences. First, we'll look at machine learning as the solid foundation, built on old-school statistics. Then, we'll get into deep learning, the powerful evolution of that, which is inspired by the human brain itself. And then, we'll get to the really juicy part, the trade-off between models you can actually explain and the infamous black box. To really get what's happening now, we have to go back, way back. And you might be really surprised to find out just how old the roots of modern AI actually are. The basic idea here is actually pretty simple, just using math to find patterns in the world. So imagine you're trying to predict house prices. What machine learning does is take a bunch of historical data, square footage, number of bedrooms, location, and it uses statistics to build a model that can predict the price of a new house it's never seen before. That's it. It's all about making decisions based on data. And what's so wild about this is just how old these modern ideas really are. We're not talking about the 90s here. We're talking about the 1700s. Get this, Bayes' theorem from way back then is still the basic statistical logic that powers a ton of the spam filters in our email today. Their simplicity, their mathematical elegance is exactly why they're still so incredibly useful. Okay, so now let's see how those foundational ideas get supercharged into something way more complex and way more powerful. This is where we step into the world of deep learning, a branch of machine learning that has just exploded over the last couple of decades. So the key idea, the big light bulb moment for deep learning, is that it's inspired not just by what the brain does, learning from examples, but by its actual structure. It's literally an attempt to mimic our own biological neural networks. Here's how it works. You've got data coming in through an input layer. Then it gets processed through a whole series of hidden layers of artificial neurons. And finally, a result pops out the other side. Now, a network is technically deep with just one of those hidden layers, but the systems we have today, they can have hundreds, even thousands. And it's that deep, layered structure that lets it learn these incredibly complicated patterns that traditional machine learning just can't handle. To make this a little clearer, you can actually think of every single one of those little nodes as its own tiny little math problem, its own statistical model. Each one takes in some data, does a quick calculation, and then passes the result on to the next layer. Now stop and try to imagine a system with potentially billions of these nodes all firing and working together. It's mind-boggling. And right there, with that incredible scale, comes a huge new problem. How in the world do you understand how these systems actually make their decisions? This is the very heart of what we call the black box problem. Right, so a classic machine learning model, something like a simple linear regression from high school math, is something we can actually get our heads around. We can look at the formula and see exactly how putting in an x gives you a y. It's totally explainable. And this quote just nails it, doesn't it? Because when you go from one simple equation to literally billions of interconnected calculations happening all at once, well, it becomes totally impossible for a human brain to trace the logic from beginning to end. So here's the bottom line. Deep learning is naturally opaque. These networks are just incredibly elaborate pattern-finding machines, tweaking millions of tiny mathematical knobs until they get the right answer. Even the engineers who build these things can't really look under the hood and tell you exactly why it made one specific decision. And that's the trade-off. We trade explainability for incredible power. And look, this trade-off, it's not just a technical puzzle for engineers to solve. It has massive implications for how we build this stuff, how we use it, and how we think about it as a society. The demand for people who can build these incredibly complex systems is just through the roof. But that also means the power to shape our future is getting concentrated in the hands of a pretty small group. And that raises a really important question. When we're building these opaque black box systems, whose values and whose biases are getting baked inside? This number is pretty fascinating. On one hand, it shows that the US is a massive magnet for AI talent, which is great. But it also points to a much bigger challenge. If the group of people building these powerful, unexplainable systems isn't really representative of the society that has to use them, how can we ever trust that the outcomes will be fair? We desperately need more diverse perspectives to challenge the hidden assumptions and spot the potential problems that a homogeneous group might just completely miss. Which brings us to the central ethical dilemma for anyone building this tech. If you can't fully explain how your product makes a decision, how can you be 100% sure that it isn't causing real harm out in the world? And that is the challenge for all of us. No question, deep learning has the potential to solve some of humanity's biggest problems, but its incredible power is matched by its opacity. Figuring out how to navigate this trade-off, how to demand responsibility when we can't always have transparency, that's not just a job for the tech folks. It's one of the most important things for all of us to grapple with in the years ahead.